Next will be the notes for section 1.3, creating definitions, and also a review of some algebra skills dealing with slope. Take out your notebooks, put these two things into your table of contents, add the date and the page, and then we'll get going. First, just a reminder that slope, the slope of the line, is a measure of its steepness. And we define slope as vertical change divided by horizontal change. And some of you might be familiar with that as rise divided by run, rise over run. The equation for calculating slope given two endpoints, or basically two any points, is y2 minus y1 divided by x2 minus x1. So let's work an example of this. The example says draw the slope triangle and find the slope of segment AB, where A is 3, 1 and B is 7, 6. So at this time you should probably pause the video and go up to Mr. Kingsbury and grab a little square of graph paper. Unless you have graph paper, then you're good to go. So set up a set of axes, x and y. We're going to put this in the upper right corner because both of the coordinates were positive. And we are asked to draw a slope triangle. What a slope triangle is basically a triangle made up of the vertical change and the horizontal change. The vertical change is shown by that green segment. The vertical change here is 5 units up. The horizontal change is 4 units to the right. You're moving 4 units from A to B. And so that is the building blocks for our slope. So here we have a slope of 5/4. It's worth noting that if you did 6 minus 1 or 1 minus 6, the order doesn't matter, just so long as you keep yourself organized. And by that I mean, if you do 1 minus 6, then you also have to do 3 minus 7, because you're taking coordinates from point A, subtracting coordinates from point B. So the order doesn't matter, you get the same slope. A couple last notes about slope. If you have a positive slope, that means you go up as you move to the right. Negative slope means you move down as you go to the right. And we'll talk more about zero slope and vertical lines later on. Let's next take a look at section 1.3, which is creating good definitions. In a geometry class, it's really important to have quality definitions for the terms that we use. And so to build a good definition, you must first classify the word, and by that I mean, what is it? Next, you want to differentiate your word, right? After you say, what is it, you want to differentiate by saying, how is it special from other similar things? It's a good idea to include a diagram or picture to demonstrate your understanding, and then always test your definition by looking for counterexamples. Counterexamples are statements that are true based on your definition, but are false based on what we know about the word. Let me give you an example. Here we have a definition. A square is a figure that has 4 equal sides. The wording in red is us classifying a square is a figure. What is it? It's a figure. And how does it differ from other figures? It has 4 equal sides. There's a problem with that. If we test the definition here, there are a couple of counterexamples that we could think of. One counterexample could be off on the far left, where even though the 4 sides are equal, based on those congruence markings, The angles clearly are not 90 degrees. If you look at the figure in the middle, this does have 4 equal sides. Unfortunately, it has more than 4 equal sides. It has at least 4 equal sides. And as a result, that's not a square, even though our definition is true. And likewise, this last figure does have 4 equal sides, but those aren't all of the sides. And so instead of the original definition that we have, a figure that has 4 equal sides, you have to be very careful about your definition. And so let's instead say a square is a 4-sided figure that has all sides congruent and all angles measuring 90 degrees. So once again, I'm using color importantly. The red is the classifying, the blue is the differentiating. How is your word different from others in your classification? Here's an example. A protractor is a geometry tool that is used to measure and draw angles. We've classified it, right? Protractors are tools, and what makes them special is that they are used to measure and draw angles. Let's take a look at another word. Parallel. Right? Parallel lines are 2 or more lines that never cross each other. I think it's worth your while to include a picture with this one. So draw 2 parallel lines. Please note that those double arrows indicate that the 2 lines are indeed parallel to each other. So on your picture, you can include the double arrows. And in terms of notation, if you were writing a sentence, you could say line L is parallel to line J based on those little, those 2 uprights. Another option would be to name the lines based on their endpoints. For example, you could say A, B, and C, D are parallel. Next, let's define perpendicular. Perpendicular lines are lines that meet at 90 degrees. And you'll note in the drawing there, that red box in the corner of lines K and line M tell me that they are perpendicular. If you were writing sentences, you would say K, and then the upside down T stands for is perpendicular to line M. A couple other definitions. We've got our types of angles. We know that a right angle measures exactly 90 degrees. So here we have some right angles and some non-right angles. Clearly the stuff on the left, each of those 3 form right angles. And we've got a couple other couple other types of angles, acute and obtuse. Acute angles are smaller than 90. Obtuse angles are larger than 90, but smaller than 180. Next, we want to talk about complementary angles. Complementary angles are any angles that add up to 90 degrees. So here we have some examples and also some non-examples. Look to the left side for the examples. We see 1 and 2 would be complementary, and 3 and 4 would also be complementary. Supplementary angles are angles that add up to 180. So again, here are some examples and here are some non-examples. You might be wondering what's wrong with the example kind of in the middle off to the right, where we have angles 1, 2, and 3. Well, supplementary refers specifically to a pair of angles, not 3 angles, but just 2. Next, we have vertical angles. Vertical angles are, I think they're kind of strangely worded, but they are a pair of angles that are across from each other based on 2 intersecting lines. Let's take a look at a picture that'll kind of make that more clear for us. Angles 1 and 2 would be vertical angle pairs because they're opposite each other and they're created by intersecting lines. 3 and 4 are vertical angles. And then the alphabet soup, we have angle AED is congruent to angle BEC, right, because they're vertical angles, and AEC and DEB. And then lastly, let's talk about linear pairs. Linear pairs are pairs of angles that are supplementary and also form a straight line. So if you look off to the left, you'll see a couple of examples that legit work out. Angles 1 and 2, angles 3 and 4, angles AED and AEC, and angles BED and DEA.